In the last class, what we have studied how to calculate the double integrals over the given rectangular region, and today we will be studying about calculating the double integrals over the non-rectangular region. So that means what we are going to do here is, suppose our region is given to be of this form. It has all the points in the two-dimension plane such that your x lies between the constant limits say alpha beta, and y lies between the variable limits. That means they are some functions of x. So say of y lies between phi1 x2 phi2 x, where both this phi1 and phi2 they are functions of x, such that this is also given to you that phi1 of x is less than equal to phi2 of x for all x lying between the values alpha and beta, the closed interval alpha to beta. So that means what is your interval? So your interval or your region, it would be defined by 4 lines. So what would be these 4 lines? The first line would be x is equal to alpha. Second line would be x is equal to beta. Third line would be y is equal to phi1 x, and fourth line would be y is equal to phi2 x. So basically what you have done, you have just replaced these inequalities with the given equalities. So you obtain 4 equations. So now corresponding to these equations, now you can plot this. Suppose on the x-axis, this is the y-axis. On the x-axis, this point is alpha, this point is beta, and suppose y is equal to phi x is some curve which is given to be like this, suppose, and y is equal to phi 2x is another curve which is given to be like this, say. Then within this region where x is equal to alpha is this line, right, and x is equal to beta is this line, right? So you have the region, this one, which is bounded between the given 4 lines. So this is your domain which is given to you, and this is obviously non-rectangular in nature. So this is non-rectangular. Now in this case, how can you compute the double integral? That is the question that we are looking for. So now let me label this. This is your curve y is equal to phi 2x. Why phi 2? Because phi 2 is greater than phi 1 at all points. This curve is y is equal to phi 1x. This is x is equal to beta, where beta is obviously greater than alpha, and here this is x is equal to alpha. These two are straight lines and these two are curves. So in this domain or in this region, we have to compute the double integral. So how can we do that? So in this case, we define the double integral double integration over the region D of some function f of x, y, dx, dy as the integral. So what is this integral? First of all, you have to compute the limits of y, because y is the variable limit. So here, if you in the previous lecture you saw, either we write the x limits here or the y limits here. So that depends. That was because your limits was constant in the previous cases. So it doesn't matter whether you write the limit of x first or y first, but in this case it will definitely matter which limits would come before the other, right? So here if I say your function is f of x, y, now here, now your limits are, if you notice, your limits are x lying between alpha to beta and y lying between phi 1 x to phi 2 x. So between these limits, first of all we should compute this. Why? Because it has some value of x, and then we will compute this because at the end we want the final answer to be a number. And how can you obtain a number? First of all, you solve the variable limits, and then you perform the integration again, and then substitute the constant values, and so that you at the final stage you obtain a number corresponding to this integration, which is the volume for this particular curve defined by this given region. So this would be, first of all, you will be calculating the limits for y and then with respect to x. So what is the limit of y? The limit of y is from phi 1 x to phi 2 x, and the limits of x varies from alpha to beta. Now you cannot write this in this case. This thing is not equal to y is equal to phi 1 x to phi 2 x integration x varying from alpha to beta f of x comma y dx dy. So this thing is not equal to this, and moreover you cannot compute this quantity. So this we are not going to do. Okay, so this is how we write our double integral in this case. And similarly in the case 2, so case 2, suppose your region D is defined like this. Say the region D is containing all the points xy such that y now varies between the limits a and b, and x varies between the limits psi 1y to psi 2y. Now what is this psi 1 and psi 2? They are some functions of y. So in this case, how would your region look like? So suppose this is my y-axis, this is the x-axis, this is origin. So here also we'll draw 4 lines. The first line would be according to this. So it would be y is equal to a. The second line would be according to this. So we have y is equal to b. Third line would be according to this. So we have psi 1y is equal to x, and fourth line would be psi 2y is equal to x. So corresponding to, say this is some point A and this is some point B, again we say phi 2x is always greater than equal to, psi 2x is always greater than equal to psi 1 of x at all points, right? So y is equal to a would be this line, straight line parallel to x-axis. Y is equal to b, this is y is equal to a, and y is equal to b again is going to be the straight line parallel to x-axis. Now between these two lines, now we have to draw this. This is some curve which is where x is given to be some function of y. So we can draw it like this. So say this is some kind of curve which is given to you, and say phi 2 is another curve which is given like this. So whatever is the region here, this region is the given region. So in this region we are to compute what is the integral. So this is our region D, and within this region we have to write down how can we compute the double integral. So double integral over the given region D of the function f of x y dx dy, this is now equal to the integration of the function f of x y. Now which limits are to be written here and here, that is up to you. Now you think and tell me what limits could appear here. First of all, we will apply the limits of x. So we'll perform the integration here with respect to x, that is x varies from psi 1y to psi 2y. So that means we'll first compute the variable limits and then we'll perform the integration with respect to the variable y. So here the limits of y will appear. So y varies from a to b. So this is how you compute the integral. So let us have a look at one question. So the question here is, evaluate the following integrals. So in this case, suppose this is the question, integration from 0 to 1 and then integration from x to square root x square plus y square dy dx. Now in this case we have to evaluate this. How can you evaluate this function? So first of all you have to evaluate this part. That means you will first perform the integration with respect to y and keep x constant. So in this case 0 to 1 dx would come as such, and what is in between would be the integration of this particular thing. So integration of x square with respect to y. Now x square is constant, so x square, and the integration of 1 would be y. So x square y plus the integration of y square with respect to y would be y cube divided by 3, and here the limits varies from x to square root x. So that means you have to substitute the value of y as x and square root x. So let me do it in the next step. So it would be integration from 0 to 1. Now in place of y, you have to first substitute the value of square root x. So it would be x square square root x plus x to the power 3 by 2 divided by 3, right? This is the upper limit, and what is the lower limit? Lower limit is x. So it would be x cube plus x cube divided by 3, and we have to first simplify this, and then we have to perform its integration with respect to x. So it would be equal to x to the power 2 plus half. So it would be equal to 2 plus half, right? So it would be equal to 5 by 2 plus x to the power 3 by 2 divided by 3 minus, here you will take the LCM, so it would be 4x cube divided by 3, and you have to compute the integration. Now what is the integration of this quantity? This is equivalent to x to the power 7 by 2 divided by 7 by 2, plus here it would be x to the power 5 by 2 divided by 3 into 5 by 2, right, minus 4 by 3 as such, x to the power 4 divided by 4. So this 4 and 4 cancels, and you have to substitute the values of x is equal to 0 to 1. So you should be very careful. What is this limit? This limit is of x. So it's better that you write the limit as x is equal to 0 and x is equal to 1. This is a good practice in general. Okay, so we just have to substitute the limits. When you substitute x is equal to 1, you will have 2 by 7 plus it would be 2 by 15 minus 1 by 3, and when you substitute 0, you have 0. So your final answer would be 3 upon 35. So this is how we define the double integral in case of non-rectangular region.